All right, so we're going to start taking a look at solving triangles that do not have a right angle in them. So we know how to deal with right angle triangles. We know we have SOHCAHTOA, we have Pythagorean theorem, we have all sorts of different strategies and tools to help us solve. If we do not have a right angle in our triangle, then we can't use any of those, and we need to think about other methods. So we're going to be talking about in Chapter 6 law of sines and then law of cosines. So the sixth one is on law of sines. So today's essential questions are, how can we use this law of sines to help us solve what they call oblique triangles? We'll talk about what that means. Using angle, angle, side, or angle, side, angle. So hopefully you remember those terms from back from geometry. So basically, if you know two angles and a side, or sometimes we can also use law of sines if we know side, side, angle. So two sides and then an angle that is across from one of those sides. So we're going to talk about those two areas today. So being able to look at how do we solve those in this first part. So oblique just means no right triangle or no right angle. So you do not have a right angle in your triangle. So it's either acute or obtuse, but nothing's a right angle. So we can't use, again, that SOHCAHTOA, and we can't use Pythagorean theorem. So if we're trying to solve and find the missing pieces in our triangle, we have to use some other stuff. And our other stuff is going to be this law of sines. So we're going to talk about when can you use law of sines, and then also what law of sines is, and then how we're going to solve with that. So the first situation, the first case that we can use law of sines is if we have angle, angle, side, or angle, side, angle. So basically you know two angles and a side. So we have two angles in the triangle and one side. Now the awesome thing about knowing two angles in a triangle and one side is you can easily find the third angle, right? Because two triangles, or in a triangle, you know two angles. The third one, we're going to just be able to subtract from 180 because we know that the three angles in a triangle always add to 180. So it's a pretty quick way to be able to solve. So that's kind of our best case scenario for being able to use law of sines. The second scenario that we can use law of sines is if we have side-side angles. So two sides and an angle, but the angle is opposite one of those sides. So we know two sides and one angle, but the angle is opposite one of the sides. So in one angle opposite, or opposite one of the angles, I should say. Or one of the sides, help me. So two sides and one angle that's across from one of the sides that's given. So two sides and one angle opposite a side. So you have one of those given sides and you know the angle across from it. In other words, if you have angle A, you know side A, or if you have angle B, you know side B. So you have two sides and an angle opposite on one of those given ones. That's a situation where we can use law of sines, because law of sines has to do with the fact that we know that the side lengths and the angles across from them are proportional. So the longest side is going to be across from the biggest angle. The shortest side is going to be across from the smallest angle. We know that those ratios are proportional. So we can say that side A is to sine of angle A, as side B is to sine of angle B, as side C is to sine of angle C. And this is what our rule is for law of sines. It's proportional. So we can use any part of those to help set up a proportion to be able to solve. You can also write this proportion with the sine of the angle in the numerator and then the side length in the denominator. It's kind of personal preference, I guess, whatever you kind of see first or you're taught first. I kind of has always done the red one there, but it doesn't matter because if it's a proportion, as long as those ratios are equivalent, we're totally fine. So you can kind of choose your own weapon there. There's a lot of different things that can happen when we look at these. We're going to start with the easiest case first. So we're going to do the angle, angle, side, or angle, side, angle. We're going to work our way through the different scenarios here. So take a look at what you're given. So you're given angle A, you're given angle C, and side A. So we have an angle, another angle, and a side. So I'm going to go ahead and use the triangle that they have. Remember that these are not drawn to scale necessarily. So when you're drawing your own triangles, do the best you can to make it easy for you to see here. But I'm going to go ahead and put in all the information I know in the picture. Sometimes that visual is really helpful. So what we have is angle, angle, side. So if I'm going to label like what kind of thing do I have here, I have two angles and then that side. The cool thing about this is you can immediately find angle B because you know two angles already. So the first thing we're going to do is find that angle B, just subtract from 180 the other two side lengths. So it's a really quick calculation to find that third angle. So go ahead and pause and do that so we can get our angle B, which looks like to me, which is why I know that this is totally not to scale, 105.5 degrees. Yikes, that certainly doesn't look like that, but that's okay. We just need a triangle to be able to label. But that should be an obtuse angle. It's definitely going to be bigger than 90. All right, so now we have all the angles, right? We have all the angles in that triangle. What else do we have left to find? Well, we have little c, right? We don't know that, and we don't know little b. So we can find both of them. So we're actually going to go ahead and calculate both. I know that it's only asking you to find the length of c, but I do want to make sure that we know how to find all the pieces. How would we do this? Well, we just set up a ratio. We're going to use that law of sines. Because we know everything about a, we know angle a and side a, we're going to be able to solve that proportion. That's the key thing with law of sines. You have to have an angle and the side that's across from it. So we can say that 10.4 side A is the sine of angle A, 31.6, as, okay, now let's just go ahead and set up the proportion for little b. So little b, side B, is the sine of angle B, and angle B was the 105.5. So we can set up that proportion and solve. By the same argument, we should be able to do the same thing for side C. So 10.4, again, everything we know about A is to the sine of 31.6, as side C is to the sine of angle C, which is the 42.9. Now, I would always go back and use the information about A, as opposed to once I find something else, that's going to be rounded. Always go back to your given information. So go back to that side and angle across. All right, now how do you solve a proportion? Well, we just cross multiply and divide, right? So we're going to multiply across the equal sign here. So I'm going to multiply. And for this first one, I'll show it. After this, I'm probably just going to go to kind of the final, what would I type into my calculator. But for this first one, let's show what we're doing here. So I'm going to multiply b times the sine of 31.6, and then 10.4 times the sine of 105.5 degrees. And then how do you get the b by itself? Well, you would just divide. So divide by the sine of 31.6. So normally I will just go right to this final calculation, because every single time we solve a proportion, we do the same thing. We multiply and then we divide. So what you're going to type into your calculator then would be 10.4 times the sine of 105.5 divided by the sine of 31.6. So it's a pretty quick calculation. It's an easy cross multiply divide. So let's get that typed. All right, couple things to note when you do this. As soon as you type in that 105.5, finish off the parenthesis. We need to make sure that you're actually dividing what you think you are. So it's sine of the angle. You have to complete that angle. A lot of people forget that parenthesis, and then their calculation is incorrect. So just be super duper careful that you actually have what you think you do there. And then we have on the bottom, we're going to divide by the sine of 31.6. The other thing to make sure that you've checked your mode. So we should be in degrees. These are triangle measurements. So if you're in radians, that is not going to give you the right answer. So just be careful. So I'm coming up with, looks like 19 point, we'll round to 10, so about 19.1. So little b is about 19.1 units, whatever those units are. So that's going to be about 19.1. I'm going to fill that into my picture. Okay, we're going to do little c the exact same way, remember, cross multiply and divide. So again, we're going to be multiplying 10.4 times the sine of 42.9 now, and then dividing by the sine of 31.6. So if you're okay, I'm going to go ahead and just write the cross multiply and divide all in one step, if that's all right. And then we're going to type that in. Now, here's a little kind of shortcut if you want. Some people will go back up and just copy this sentence, because the only thing that's changing is the 42.5. So I don't know if that's faster or shorter than typing in the whole thing. Again, you can decide. So some people just copy and type over, so they have their new angle measurement, and then they can make that calculation. So you decide what's easier for you. If it's easier just to type, that's fine. Looks like we've got about 13.5. All right, so let's go back up. I'm going to label that on my picture. This one was 13.5. Now let's check reasonableness of answers here. Remember, these are proportional. The shortest side should be across from the smallest angle. So angle A was actually the smallest angle. Its side was 10.4. 42.9 angle C is the middle angle size, and it was across from 13.5. Is that reasonable? Well, sure, it's bigger than 10.4, but not by much, because 42 isn't that much bigger than 31, so they should be pretty close together. Then look at your last side, 19.1. Significantly bigger? Well, yeah, because it's across from the angle that's significantly bigger, right? So always double check that. It's so easy to type things incorrectly in your calculator, so we want to make sure that we're solving the right way. So we'll make sure that we have everything we need there. Alrighty, so now here's where things get interesting. When we start talking about two sides and an angle, or two sides and an angle opposite one of those sides, that's when things get a little bit crazy. We have something called the ambiguous case. I want you to take a moment and Google the word ambiguous. Google that word for me quick. What does ambiguous mean? Because that'll help you understand what we have going on here for side-side angle. So ambiguous. So ambiguous means things are unclear, uncertain. We can't really know right away. And that's exactly what happens when we have side-side angle. There's actually three different outcomes that can happen depending on what kinds of sides and angle measurements that you have. So the three different things are, you can either have no triangle at all. In other words, you can't physically make the picture that they're talking about. So there's no triangle that we're ever going to be able to deal with. The second possible scenario is that there's only one triangle. There's only one way to draw what they're talking about. So we can only have one answer. But unfortunately, the super ambiguity part of here, the ambiguous case, is sometimes we have two triangles. In other words, there's two different ways to draw the picture that they're talking about. You can draw an obtuse triangle or you can draw an acute triangle. So we're going to have to be able to figure out what kind of situation we're having and then be able to solve. So we're going to walk through all of the cases, and I'm going to be giving you kind of a shortcut note here to be able to tell, just like note sheet, that it's kind of a go-to to be able to have all these cases in front of you so we can start getting comfortable with them. So we're going to talk through the different things that can happen. So first thing that we're going to deal with is when the angle that you're given is acute. So the given angle is acute. Now, we have to have some way to talk about this angle. So we're going to say angle A. So we're going to say angle A for this. So A is acute. But it wouldn't have to be angle A, right? It's just the angle that you know. So we have two sides and an angle. Whatever angle you're given, we're going to call that angle A, but it could be anything that's happening in that situation. All right, so there's a whole bunch of different scenarios that can occur. We're going to walk through. I'm going to draw a picture so you can understand what's happening in each one of these. So first situation is when you have a side A, so across from angle A, that's too short. Okay, so I'm going to have you draw the pictures as we go. So I'm going to put these in for each one of these. So if I have my angle A here, which is acute, less than 90, my angle B is going to be somewhere over here in that neck of the woods. Angle or side B would be across from it, and then my side A. All right, so I'm going to get rid of the B. So these are the three pieces of information you would know. Side, side, angle. So side, side, angle. Those are the three pieces I'd be given. So whatever labels they are. So angle A is acute. Here's a situation that we're going to talk about first. When side A is just too short, you can't just pick any numbers you want to make a triangle, right? They have to actually reach to make the triangle. So I'm going to go ahead and put the height of my triangle in here. So I'm going to call that H. So I'm going to look at this and say, okay, well, if the A is shorter than the height, like the shortest distance from a vertex to the opposite side is the perpendicular distance, that height, right? So that side can't be shorter than the height. So if the A is less than the H, so if that side across in the angle is shorter than the height, then there's no triangle. There's none. We can't draw that. It doesn't make sense. So we would have to be able to calculate the height and check to see is it longer or shorter. If it's shorter, we are completely out of luck if that side across, because it's not going to be a triangle. We physically can't draw that. All right, well, what if it's equal to? So let's draw another picture. So what if you have your angle A again? So we're just going to walk through the different possibilities. Here's my side B. What if side A is actually equal to the height or perpendicular? So what if the A is equal to the H? Well, if it's exactly the height, that means it's perpendicular and it's actually a right triangle. And there's only one way we can draw that. So there would be one triangle in that situation, and it's actually a right triangle. And I would be able to solve for all the missing pieces. So if it's actually equal to the height, it's going to be a one triangle situation. So, and again, remember, the three things that we know are those two sides, A and B, and that angle across. So that's what we're given. All right, now here's two other possibilities, and I want you to see if you can draw these with me. So what if you have an angle A? So again, same acute angle that we were doing. Oh, I'll put it on the outside so it looks like all the other ones here. So trying to draw so we can talk about what's happening. And we have our B, so our side B, that's given to us. What if side A is longer than side B? So again, here's our height. What if the side A is bigger than B? So A is longer. So A is longer than B, or even equal to, because it could be an isosceles. If A is longer, that means the only way you can draw this triangle is having side A go away from B. Because if A is longer or equal, it can't swing back and come back in this direction, right? Because it would cross over. So if A is longer, the only way you can draw that triangle is with side A going away from where side B is, or away from that vertex A. So if A is longer, there's only one triangle there as well. It's not a right triangle, but there's only one way we can draw it. It has to go away because it's longer or equal. If it was isosceles, it would be the same thing. We couldn't possibly swing that side A in any other direction. So we're kind of stuck there, right? That's as far as we can go. All right, let's take a look at the last acute situation. And this is the one that gets a little bit tricky for people to visualize. So I'm going to try to draw this as well as I can here so you can see what's happening. So let's start with this. So we're going to start with our angle A, and we have our side B, and we have our height. So let's get all of that in there. So we have our height. So what if this last situation, we talked about when the A was less than the H, we talked about when the A was equal to the H, when the A was bigger than the B. Well, what if the A is less than the B, but bigger than the height? So what if that A value is bigger than the height, so I know I can actually draw the triangle, but it's less than side B, so it's shorter than side B, which means I could swing that in two different directions. And that's what we want to talk about this last case. So I'm going to go ahead and draw in two different scenarios. So A is shorter than B. So I'm going to go ahead and draw a side that looks shorter than B. So here's my side A. That's one way I could draw the triangle, right? I could draw it with the A going away from vertex A like I did the last time. Or because A is shorter than B, I could also swing it, and I'll draw this in a different color. I could swing it back coming this direction, and the A could have been there as well. So I could have drawn the A going away from vertex A or coming back towards vertex A. So I really get then two different triangle options. There are two different triangles. There's an acute and there's an obtuse. So the acute triangle is that red one that I did. So I'm going to draw the two different versions here. So the acute triangle that I'm talking about is the one where the A is, make it shorter so it looks like it. The acute one is where that A is going away from. So the A, I'm actually going to make the B even longer so it's super obvious. All right, so our B and our side A. So the acute version would be like this. And then I'm going to do the obtuse version, which was the blue one. So the obtuse is where we swung it back instead. So I still have that same given side A. My B is still the same, so same deal. But that A, instead of going away from vertex A, is going to come back this direction, and that B, our angle B, is going to be obtuse instead of acute. So that's our A and that's our B. So in the first situation, my angle B would be less than 90. In that second situation, it's greater than 90. So in this original picture, here's the acute version of angle B. But if I swing that side over instead and come back towards it, then my new angle B, so we're going to call that B prime just so we have a different symbol here, is actually obtuse. So there's two different things that can happen. So either it's acute or it's obtuse. So there's two triangles. So if it's bigger than the height, if that A that you're given is bigger than the height, that means you can draw the triangle, but it's less than side B. That's when we get the two triangles scenario. So there's a lot of different things can happen. You can see why they call this the ambiguous case, right? That we don't know until we get into it. Now, thankfully, when the angle that you're given is obtuse, we have a way easier situation. So if the given angle is obtuse, we have a little bit easier. All right, so if the given angle is obtuse, we're going to go ahead and draw the couple pictures for this. So this one is a lot easier. So when we think about the given angle being obtuse, so I'm going to go ahead and draw myself an angle A. We have our side B again, and we have our side A. So let's talk about the two different possibilities. First one is exactly the same as the first one we did before. If the A is less than or even equal to the B, the side across from that obtuse angle is smaller than the other side. Think about that for a second. What do you know about the side across from an obtuse angle? wouldn't it always have to be the longest in the triangle? So it can't be shorter or equal to. So if you have a situation where the angle, or the side that's across from the angle, is shorter or equal, there's no triangle there. There's no solution. You can't physically draw that. So it's a really quick check. Nope, that doesn't work. So it has to be longer. So in the situation where it's longer, then we know we're going to have one triangle. So if the A is longer than the B, so if the A is greater than the B, then we have one triangle. And we can use our law of sines to help us solve for it. So the whole idea here is that really looks like not like triangle. The whole idea is that we'd be able to solve using law of sines then. So it's really just looking at the size of that side across. It's a good starting point for any of these. So if the angle is obtuse or acute, we have to make our choices based off of that. So this little sheet that you have that kind of has everything on there, we're going to talk about how you find that height. This is part of what we're going to be dealing with every single time we look at a new situation. So let's talk about how we calculate the height, so you have that on there. The easiest way to think about that, and I'm going to go ahead and just draw a triangle here and put in the labels. So here's the height, here's side A, or angle B, angle C, little a, little b, little c. All right, so I want you to take a look in this triangle right here. So think about what you would know when you're given this information. You know angle A, and you know angle or side B, and you're trying to find the height, because that's what we need to use to determine how many triangles we have. Think about SOHCAHTOA in that right triangle. The H is the side that is opposite, and the B is the hypotenuse. So which trig ratio is opposite over hypotenuse? Which one is opposite over hypotenuse? That's sine, right? So sine of angle A is equal to H over B. So solve that for H for me. So the height would be B times the sine of A. In other words, it's always sine of the angle times the other side, whatever those labels happen to be. So you'll see that right up here on the top. That's something to note. That's how we calculate. And again, the labels can change. So it's sine of the angle times that other side. So we're going to go through this process and see if we can figure out how to solve these triangles. So we're going to do several of the cases in this part 1, and then we'll do other cases in part 2. So let's talk through the different scenarios. It's always going to be looking at what do I know, and then what does that mean? All right, so it says if possible, because remember, it may not have a solution. All right, so we're given one angle, and we're given two sides. The question is an angle across from the side? Yes, because we have the same letter. So angle A, side A. So we have, in this case, a side-side angle. So I know I'm going to be using law of sines. The question is, do I have any solutions? How do I know? All right, so let's talk about what we're given. So we are given an acute angle, right? So acute angle. And we know it's side-side angle. So it's acute, two sides, one of them is across. So because it's acute, that means I'm looking at these first 4 yellow cases here. So it's going to be acute, that one angle I'm given. So I need to figure out how this side that I'm given, A, compares to side B and also the height. So I need to make that calculation and know that I have an angle that works. So let's see, or a side that works. So let's take a look. How does the side A compare to the side B? Well, the A is greater than the B, right? It's a bigger side. So let's take a look at those 4 possibilities. If the A is bigger than the B, I'm right here. That means I don't even have to calculate the height. That's the only one I don't need the height for. I know it's going to work because it's longer. I'm going to be able to draw that triangle. So if you wanted to draw the picture, just so you have an idea of what kind of thing we're dealing with here, this is a 28-degree angle, angle A. So this side is 50 and side B is 20. So yeah, I can do this. I can solve. So that means I'm going to have one triangle. So that's the nice situation for the ambiguous case here. It's the one that I can just know immediately because the side across from the angle is bigger. All right, so what can we solve for then? So let's talk about the actual solving. Because I know everything about A and I have side B, the first and only thing I can solve for is angle B. So I'm going to go ahead and set up that law of sines. So 50 is the sine of 28 degrees. As little b, 20 is the sine of angle B. All right, so we're going to do our cross multiply divide like we normally do. So when I cross multiply divide, that would be 50 times the sine of B. And again, on this first one, I'll show more, and then we can kind of scale back. Then 20 times the sine of 28. And then to be able to solve, I need to get sine of B by itself. So I'm going to divide by 50. So I'm going to divide by 50, and that's what sine of b is. So a little bit different than in the last situation. I'm not done yet, right? I have to figure out what angle b is. So I need to undo that sine. So to undo sine, I do inverse. So what I'm actually going to type into my calculator is inverse sine of that whole thing. We're going to talk about what that looks like. And normally moving forward, I will probably jump either to one of these steps right away because I know what's going to happen, because the same thing happens in every single one of these proportions. We cross multiply and divide, but we're just trying to show a little bit more on this first one. So let's see if we can get that typed in. So we're going to start with, I think I'm going to do what's inside the parentheses first. So 20 times the sine of 28. And here's where people mess up. So please, please, please don't forget your parenthesis. Finish off that parenthesis and then divided by, let's see, divided by 50. Can remember the number there. And we get a decimal. Now that's what sine of b is. So we need to do inverse sine, again, of our answer to get that value. Be sure you're in degree mode, which I was because I didn't change it. So that's 10.8 degrees. So when I'm looking at that value, that's my first angle measurement. Okay, now the cool thing about this is now I have two angle measurements, right? I already know angle A because it was given to me, and I have angle B, which is what I solved for. So the next easiest thing to solve for is the third angle, and we're just going to subtract from 180. So go ahead and do that and see what you get for that third angle. All right, so I came up with 141.2, so this is definitely an obtuse triangle. So we have all of our angles, which is great. So now what do we have left? What's the only thing we don't know? Well, the side across our little c. So I can go back again and use law of sines because I know everything about everything else, and I can set up that proportion. Now again, we always want to use given information. So go ahead back and use that angle A and side A. It's going to be more precise. If you use the angle B, that's a rounded number. So we want to go back and find that third side using the given information. So we're going to find the third side by using law of sines. So we're going to set up our proportion and we're going to solve. So let's go ahead and do that. So we are going to have our 50, so remembering these side lengths here. So side A is to the sine of 28 degrees, as little c is to the sine of our angle C, which we just calculated to be 141.2. So we're going to cross multiply and divide. Notice we're finding a side, so no need for an inverse here. It's just cross multiply and divide. So 50 times the sine of 141.2 degrees divided by the sine of 28 degrees. Don't forget, finish off those parentheses when you're typing that in. All right, so when you take a look, finish off that parenthesis after the 0.2, after the 28, and we get 66.7 for our side C. So side C is about 66.7. I'm going to go back up to my picture. Let's check for reasonableness. This is always an important part of our conversation. Is the biggest angle across from the longest side? Sure is. Smallest angle across from the shortest side? Yep. Make sure that that makes sense, because if you've typed anything in wrong, that's a great place to check for that reasonableness. So this was an acute triangle. So the angle that we were given was acute, but the side opposite the angle was bigger. One triangle, I know for sure, and I can go ahead and solve using law of sines. All right, now we're going to walk through some other scenarios so we can talk about some more things that can happen. All right, so again, we're going to analyze what we know. So we're given, looks like one angle and then two sides. Our angle that we're given is acute, so we're given an acute angle. And then we do have the side opposite it, right? So we have side A to go along with angle A. So we're given an acute angle and it's side angle. Okay, so now we have to figure out our calculation here. The first thing I'm going to do is check and see how the side across compares to the other side. So 3, how does it compare to 8? It is definitely less than. So the A is less than the B. So let's go back to our pictures here. If the A is less than the B, that means I've eliminated this possibility. It's not that. It could be this, right? So it could be that situation. It could be one of these other two as well. I don't really know because I don't know how it compares to the height. So I don't know if it's equal to the height, if it's smaller than, or if it's less than. So I'm going to have to find the height in all of those other scenarios. So I'm going to have to calculate my height. So let's go ahead and do that. Remember, that's B times the sine of angle A. We talked about why that was when we looked at our right triangle. So let's calculate that height. So 8 times the sine of 30 degrees. So let's go ahead and calculate that out. Sine of 30 is a half, so that is going to be 4. All right, so let's see how that compares. So my side A, which is 3, is less than the 4. So the 3 is less than the 4. That means the A is less than the height. So I'm comparing now, it's less than the other side, but it's even less than the height. So what does that mean if it's less than the height? Well, we're right here. There's no triangle there. That side A is too short. There's no way I'm going to be able to draw that. So because the A is less than the 8, so this is your reasoning here. In this situation, in a side-side angle situation, that tells me then that there is no triangle. I am not going to be able to draw this because the side is shorter than the height. The height is the shortest distance it can ever be. So we have to calculate that height if that side A is shorter than the other side. We just don't know what scenario we have until we calculate that. All right, let's try another scenario. I'm going to change one thing. All right, so we still have that given angle. That's acute. So we're given an acute angle. So we have an acute angle, it's 30 degrees, but we have two sides. The side is across from the angle, same letter. So it's an acute angle, side, side, side. First thing I'm going to do is compare those two sides. How does it compare? Well, the 4 is definitely less than the 8. So that means the A is less than the B, which means if I go back to my pictures here, if the A is less than the B, let me just get rid of this. If the A is less than the B, I've got either this situation, or this situation. I am eliminating where it's greater. All right, so then I have to calculate my height. So let's go ahead and do that. Now, if you remember from the last one, this is basically the same thing. I just changed the 4. So let's calculate the height. So that's B times the sine of A. So that's 8 times the sine of 30 degrees. So the height is 4. So we knew that from the last one. So how does the A compare with the height now? So we need to make that comparison. Well, the A is 4 and the height is 4. So the A is actually equal to the H. So what does that mean? Well, that means I have exactly one triangle. It's the same height, the A value. So there's only going to be one way to draw that. It's a right triangle. So because I have an acute angle and it's side-side angle, and because I know the height is equal, that means it's going to be a one triangle situation. So we have one triangle. So how do we go through and solve? Well, we can find all of those missing pieces. So if we think about what we would do, we do the same thing as we would in the last one. We could set up law of sines to find angle B, right? So we can go from there. Or because this is a right triangle, we could also use SOHCAHTOA, so being able to do that as well. So I'm not going to solve all the way through the rest of this one. You can go ahead and solve out the rest if you need to. I want to focus more on the how do I know how many triangles I have. I think the setting up of the proportions is probably going to go okay for you. All right, let's try the next one. Then we'll do a little bit of solving on these. All right, so take a look at what situation we have. Now we're given a one angle and two sides across from it, but look at what kind of angle we're given. In this case, we are given an obtuse angle. So we have an obtuse angle, and then the side across from it, same letter, right? So it's side, side, side. So if it's obtuse, we're in great shape here. All we have to do is compare the sides. So let's take a look. Which side is across from the angle you're given? Look for the same letter. It's the 6. How does the 6 compare with the 9? Well, it's shorter. That means the A is less than the B. Is it physically possible to draw an obtuse triangle when the side across from the angle you're given isn't the longest? Nope. Not possible. It's too short, right? We can't do that. So this, because I know it's obtuse and side angle, and because the side across is shorter, what that tells me is there's no triangle. So to be able to justify and know, these are kind of the two key pieces of information you'd have to be able to say. I know it's obtuse, that's the angle I'm given, the side across is shorter, doesn't work. Let's take a look at our last one. Again, probably not to scale when you look at the numbers that they're giving you. So 110 degrees is the angle A. They're giving you side C, so little c is 16, and side A which is 25. And they want you to find side B. So this is a side-side angle scenario again here, but the angle that you are given is obtuse. So we have an obtuse angle, side, side, side. Side, side angle, sorry. Can't write my letters here. So because it's side, side angle, let's make that comparison. The side across from the given angle is the 25. How does that compare with the other side that you're given 16? Well, it's bigger. The A is bigger than the B. What does that mean? Let's go back to our pictures. In an obtuse situation, yep, it's got to be longer, right? Because it has to be the biggest side. So we know we're going to be able to solve, and this one is going to have one triangle. So this one I will go through and actually do the solving for so you can see what that looks like. So the only thing that I can solve for is going to be this angle C. It's the only piece of information that I can do. So I know everything about A. So 25 centimeters is to the sine of 110 degrees, as little c, 16, is the sine of angle C. And remember how we solve these proportions, cross multiply and divide. I'm going to abbreviate a little bit on this one, so hopefully we can shorten up the work here a little bit. So 16 times the sine of 110, and then divided by 25 would be what the sine of C is. Now remember, we don't want sine of C though, we just want angle C. So we do inverse on both sides. So what you're going to be typing in is the inverse sine of 16 times the sine of 110 degrees divided by 25. Don't forget to finish off those parentheses when you are doing that solving. So make sure you finish off that parenthesis there. And then now we're going to do inverse sine of our answer. Make sure you're in degree mode, of course. And we end up with a 36.9. So angle C is about 36.9 degrees. So we have that second angle. Now remember, again, if you know two angles in a triangle, we can find the third angle next pretty easily. We just need to subtract from 180. So we're going to subtract those others. Subtract from 180. So that would be angle B. So go ahead and do that. So subtract from 180 the 110 and the 36.9. And we'll get our angle B. And actually, I guess when I go back and take a peek at it, it probably should have been 37, right, when we follow our rounding, if you're wondering about that. So I'm going to go ahead and make my life easier here. If you already had the 0.9, that's fine. But actually probably would be 37. I think that looks like a little bit better following our rounding rules. So angle B would be 33 degrees then for that second or that third angle. So 33 degrees. And I'm just going to make that a 37 just to make our life easier. So what's the only piece we don't know? Little b. So how are we going to do little b? We're going to go back and do a law of sines proportion. And remember, you always want to use the given information. So I'm going to go back and I'm going to find my third side. So I'm going to find that last side. So find the third side, and we're going to use law of sines. So I'm going to go ahead and set up 25 is to the sine of 110 degrees. But now as little b is to the sine of angle B, which was 33 degrees. So we're going to use law of sines to help us find that last piece. So we're always using law of sines twice and subtracting from 180. It's kind of the same work every time. So cross multiply and divide. So little b would be 25 times the sine of 33 degrees divided by the sine of 110 degrees. Again, don't forget to finish off those parentheses. All right, so what I'm coming up with, if we round to the nearest tenth, looks like it would be about 14 and a half. And again, notice how I finished off the parentheses. No inverse necessary because I was solving for a side length, right? So we don't need an inverse because I wasn't solving for an angle. And this was in, I believe, what units here? Centimeters? So 14.5 centimeters. Let's go back and check for reasonableness here. Always a good idea. Is our smallest angle across from the shortest side? 33 is across from the 14. That is definitely the shortest. Biggest angle across from the biggest side. Yep, that's what was given. So I have a pretty good idea of what's going on. So we have dealt with all the scenarios in this part one other than the two triangles. We talked about a none and a one for obtuse. So we did both of these. And we did a none, a one, and a one for this ambiguous case. What we're going to deal with in part two is the two triangle scenario, and then also we'll deal with some area things. So this will be plenty enough to talk about for part one. Always trying to analyze what do I know about the triangle, and then what does that mean for how many solutions I have.